Alright, we're going to be looking at some patterns and sequences. I love this stuff. You see patterns and sequences all over the place. You've probably seen it on carpets or floor tiles. And right here we have the number of dogs and the number of legs. There's a pattern that's going to happen here, as Scooby will tell us. And hopefully you guys know who Scooby-Doo is. If not, I will feel very old. But we have one dog, we have 4 legs. If we have 2 dogs, we have 8 legs. 3 dogs, 12 legs, and so on. So you can see kind of each time we do this, there's a little pattern, and we're going up by 4, and up again by 4, and so on and so forth. And you can kind of catch the idea. And we're also, although you don't see it, we probably don't have to know this yet, we're also multiplying the number of dogs times 4 to figure out how many legs. Or if it was a car and the car's tires, we'd do the same thing. We'd multiply by 4. So Scooby has an idea for this. The number of legs follows a sequence. First term is, well, term. It's just the number that's that you're on in the sequence. So here we have the first term is 5, the second term is 11, and so on. And we just call this to be the value of the term. And another word we can use for term is position, as we'll see. So in this particular instance, we're trying to figure out what's in this box right here. If you can just follow along with the pattern, we should realize that going from 5 to 11, we go up by 6. And from 11 to 17, again, we go up by 6. And if we're going by the same amount each time, we call that an arithmetic sequence. So that's what we have right here, because everything goes up by 6. So if this keeps going up by 6, the pattern would have us think that this is 35, and that's what they're looking for you to put right there. So we get 35, and as our smiley face would say here, well, what would the value of the 6th term be? So here's our 6th term, it would be 35 here. But instead of the numbers going up, the numbers are going down. So if the numbers are going down, naturally we're going to assume it's subtraction. And we are taking away 11 each time. 79 minus 11, 68, so that works. 68 minus 11 is 57. And you're probably asking yourself, why do you have to go each time and say minus 11? Why don't you just go down to the bottom term, do 57 minus 11, which is 46, and just put your answer there? Well, we're going to see why in just a second. It's a good idea to always go through each term and put minus 11. By the way, this would also be classified as an arithmetic sequence. There's that term again. And it's just like this one, except this one we were adding the same amount each time. And on this one, we were subtracting the same amount each time. So, like I said, if you wanted to say to yourself, okay, this is going up by 5 here, and I know it's going up by 5, so I'm going to skip to the last step here and put my answer is 72, because I know 67 plus 5 is 72. Well, watch what happens. This, from 41 to 49, doesn't go up by 5, does it? So it's kind of a little bit of a wolf there, if you will. That goes up by 8. And then it goes up by 5 again. And you're going to see in this pattern, this sequence here, that it's going up by 5 and 8 every other time. So this would not be classified as an arithmetic sequence because it's not going up by the same amount each time. And as we'll see here, our answer of 72 won't work because we're supposed to add by 8 right there. So this answer really should be 75. So we'll put that there, and we'll make that wrong. So now what we're trying to do is figure out the next 3 terms. So if I look at this one here, to go from 5 to 10, I would be adding 5. And from 10 to 15, I'm adding 5. So it's looking like we're going to have an arithmetic sequence here, but again, good idea to try them all out. 15 to 20, again, we will be adding 5. I apologize for my messy writing as usual with this computer program. So for the next 3 terms, this next term would be 20 plus 5 is 25, 25 plus 5 is 30, and then 30 plus 5 is 35. All right, I almost said 31. This next one's a little bit more difficult because we haven't seen it yet, but you'll see it right away. So if I go from 4 to 8, I'm adding 4, of course. But then I go from 8 to 16, and I'm actually adding 8. And from 16 to 32, adding 16. So that's not really the pattern. Whenever you realize that you're getting a different number each time, the first thing you should try is the other operation that makes numbers go up, which in this case would be multiplication. So 4 times 2 gives us 8. 8 times 2 gives you 16. And 16 times 2 gives you 32. So that's really the pattern. So if we do these out, 32 times 2 would get you 64. 64 times 2, well, 60 times 2 is 120. 4 times 2 is 8. We'll get you 128. And then 128 times 2, 120 times 2 would be 240. 8 times 2 would be 16. So 240 plus 16 would give you 256. And then we have another challenging problem here. 8 to 4, we would divide by 2. And then 4 to 16, we'd actually multiply by 4. Now this might not work right away, and if it doesn't, we'll try subtraction by 4 and not multiplication, adding by 12. But as it turns out, we divide by 2 again here, so we have one of those every other type of patterns. 8 times 4 gives us 32, and then this would be divided by 2. 16 times 4 is 64. 64 divided by 2 is 32. And then the last one, 32 times 4 would be 128. And just make sure you notice I continued to draw these little arrows here each time. Otherwise, you'll lose track.